thing we need to understand is what is physical and chemical change, right? So let's try to understand it in some examples. But before that, I want to ask, what is a physical change? What is a chemical change? Trisha, what is a physical change? Any ideas?
It is a change, like when when a new substance is being formed.
Yeah, when a new substance is formed, but that is a chemical description. Can you give me an example? Anyone unsure? Can you give me an example of a physical change?
When you burn paper.
Is that a physical change? That's
Um,
a chemical change, right? Adlin, what is a physical change? Can you give me an example?
Ice melting, sir.
Ice melting, right? Isn't it? Right? That's a physical change. And when Trisha said a new substance is formed, a physical change, the substance remains the same, isn't it? Right? Take the case of paper. Like what Anshul said about burning the paper, instead, what I take is I take a blank sheet, okay? I take a single sheet, I tear it off my book, and I crumple it. You know, you make it into a ball, right? So the paper has now become into a like paper ball in this case. Now, if it were up to me, I can open this paper up, right? I can open this ball and I can, you know, take out the creases as much as I can. I would still get the piece of paper in that case. Trisha, Adlin, Anshul, is that clear? I would still get the piece of paper. So is that a new substance form? No, right? It's still the piece of paper in that case. So that is why we need to understand a clear distinction between a physical and a chemical change. Let's try to understand that right now. Okay. So first thing is, as we'll be discussing chemistry as a separate subject, which you have been doing since last year. What is chemistry? It is the study of matter that and changes it undergoes. Changes can be with respect to composition, with respect to structure, or properties in this case. Okay. So first thing is that we need to understand here is in order for a substance to undergo a particular change, whether a new substance is formed or not, and can the reaction be reversed or not in this case. Do you guys understand? These two aspects must be understood very, very clearly. So, is a new substance formed? Maybe, maybe not, right? If a new substance is formed, then the change that we are looking at is a chemical change. Do you understand? Can the reaction be reversed in that case? Likewise, how Anshul said, burning of paper. Can I take the burnt paper? Okay, now it has turned into ash and I can make paper out of it. So I guess it's a irreversible process, isn't it? Isn't it? So can the reaction be reversed? No, right? So that means the process that we're talking about is a chemical change. Same, and as Adlin said, you take a piece of ice and you melt it. So is a new substance formed in that case? Anshul, is a new substance formed when we melt ice?
no, sir.
No, right? Isn't it? And can the reaction be reversed in this case? Um, Trisha, can I reverse the melting of ice?
Yes, sir.
Yes, right. So there is no new substance formed, and I can reverse this process. So therefore, this is a physical change here. Therefore, what is a physical change? Physical change is where no new substance is formed. Change is temporary. There is no change in mass. What is a chemical change? New substance is formed. Change is permanent. Okay, and mass of product may change depending on what we are actually looking at. This third point we'll be discussing it in detail when we come to the actual chemical reaction. All right. So in today's class, we'll be learning how to write chemical reactions. Okay, that's the basic thing we'll be doing. So in order to understand what a chemical reaction is, first we need to understand what a chemical change is. We now know what a chemical change is. It is where a new substance is formed and the process is irreversible. The change that happens is a permanent change. That is what is known as a chemical change. Now, the process that leads to a chemical change is known as a chemical reaction, where you have an initial substance known as the reactant, which undergoes a chemical change to give you the final substance known as the product. So the first process to understanding how to write a chemical reaction is to first understand how does a chemical reaction is written down. Okay, so when we started writing the chemical reactions, when we started understanding that how does a chemical reaction occur, we started to write them in word equations. Okay, so in front of you, there's a simple reaction. Magnesium reacts with oxygen or burns in excess of oxygen to give you magnesium oxide. It's a very simple statement, okay, but it does not like if let's say someone is writing a chemical reaction, it does not translate well. Okay, as in you do not know what the chemical reaction shows, right? You do not know what the symbols are. You do not know how much of the amount is there. Okay, all this information is hidden here. So then we write it in the form of a word equation. Can you guys see? Magnesium plus oxygen gas gives magnesium oxide. This equation that is in front of you is known as a word equation here. Okay, this equation in front of you is known as a word equation. Let's write it down. This is known as a word equation. Clear? But this is also very tedious to write. Like if I have to write this 5 or 10 times, like I have to mention it somewhere, it's very tedious, right? I have to rewrite the words again and again and again. So there's an easier way in order to write this down. Okay. So how I can write it down? I can write it down in the form of a chemical equation. What is the chemical equation? That involves chemical reactants, or not even chemical reactants, reactants and products in the form of their formulas, chemical formulas. You remember writing chemical formulas before it, right? We spent a good 2 to 3 classes writing the chemical formulas. So that is what we are going to write it down here. Okay, so magnesium translates to Mg. Oxygen gas translates to O2. Okay. Anywhere where gas is written, that gas tends to be either diatomic, triatomic, depending on the substance, right? We have learned all of this in grade 9, but we have now utilizing it. So Mg plus O2 gives magnesium oxide, which is MgO. Okay. I know all of us have written this down, so it's fairly simple. Please write it down. Okay. So in order for us to write a chemical reaction, it's fairly simple. Write the chemical reaction in the form of a chemical equation. All right. We are still about 30% of the way in order to understand how to write it fully, but this is the start to everything that is in front of us. Is that clear? Let's write it down. Okay. Similarly, let's write down the next one. Sodium bicarbonate when heated gives sodium carbonate, carbon dioxide, and water. So I can write it as short as possible in a word equation, but it's not convenient. So the best way to write it down is NaHCO3, sodium bicarbonate. Okay. All of you guys are already aware how to write the formulas in this case, right? Okay. Now, the thing is, it says when heated. So heat has a particular sign. It is actually written as a triangle. This is the symbol of heat. Clear? So when heated gives you sodium carbonate, Na2CO3 plus CO2 plus H2O. Okay. Last one, sugar plus when heated it gives carbon plus water in this case. So sugar is actually made up of carbon, hydrogen, and oxygen. So the best example of sugar is glucose. Okay, so I'm going to write it quickly. When heated, so I have to write the triangle as well. C6H12O6 on heating gives you CO2 plus H2O. Is that clear? So the thing is that this chemical equation is not done yet. There are a few things which are missing. Okay. Key points, for example, if I look at any of these reactions, for example, Mg plus O2 gives MgO. It's fairly evident that magnesium reacts with oxygen, it gives you magnesium oxide. Okay. But let's say if I want to visualize this chemical reaction, I cannot do that. You know why? Because I do not know what is the state of it. For example, what is the state of magnesium? Is it a solid? Is it a liquid? Is it a gas in this case? What is the state of oxygen? Okay. I can only imagine how the chemical reaction must go on. This becomes difficult when we are looking at substances which we are not aware of. So we need to introduce something which actually helps us do that. This is known as a state symbol. Okay, a state symbol in a chemical reaction helps us ascertain what are the state symbols or what is the state of a particular species. Whether it be reactant or a product, it will tell us that. Okay, so these state symbols can be of actually four types. These are solid, liquid, and gas. Okay. And the fourth type is slightly different because we have not discussed it. Neither it will pop up. It has popped up in any of the conversations previously. This is known as aqueous. Okay. It is written as dissolved in oxygen. So what is dissolved? Something which is capable of forming certain species known as ions. Okay, as we move forward, we will understand more of it, but for now, this much is enough. Clear? All right. I know you guys are aware of ions, but I want to take a little bit more, expertise on this before we start actually understanding that. Okay. Now you might ask, "Sir, how would we know the state symbols of every single species, right? Isn't it? It can be daunting in this case. So the thing is that this will come eventually. Okay. It's something which you keep on doing and doing. By the end of the year, I do not even have to tell you, you would know it yourself. Got it? Okay, let's start with the first one. So carbon plus oxygen gives carbon dioxide. Okay, carbon exists as a solid in this case. Okay, so what I'll do is, in order to write the state symbol, I'll write it towards the right hand side and at the bottom here. So I'll write it in small, solid like this in brackets. Okay, oxygen obviously is a gas. So I'll write G here. Right. Now CO2 is also a gas in this case. So I'll write this. Okay. Now, one more thing I'm adding here, which is not given here, but it is written regardless, is that in case of products, we are not able to see whether something is evolved or something is precipitated in this case. So since CO2 is a gas, it is given off. So we show it by an arrow pointed upwards. Is that clear? Because CO2 is a gas, I can show it as an arrow upwards in this case. Clear? Any doubts, any questions? Okay, I'll fill up the next one as well. So CO2 is a gas. Water is a pure liquid. Okay, you'll see that water being the only pure liquid in this case. C6H12O6 is a liquid as well. Okay. All right, no, not a liquid. It's a solid, by the way. All right. So sugar, right? And O2 is a gas. Again, it is a gas which is evolved. So an arrow shown upwards here.